All right, so again, we've now done kind of two examples with limiting reagents, and this next example will still be about limiting reagents, but we're introducing a new concept called percent yield. So guys, percentage yield is just a really fancy way of saying how well did you do in the experiment, okay? It's very similar to a test, like a percentage on a test. How do you calculate what you get on a test? You take what you got, you divide by what you should have got, and then multiply by 100. Percentage yield is the exact same. You take what you got in the experiment, you divide by what you should have got, theoretically, which we get from stoichiometry, okay, calculating it, and then you multiply by 100. That's it. Now, before we can do that, all right, let's read this information, see what we have, and then see what we need to get. So it says a student mixes together two solutions, forms a precipitate. Okay, so we've got two aqueous chemicals reacting to form a solid plus something else. So let's just write out that reaction before we have anything to do. So it's giving us potassium phosphate. Okay, so K3PO4. Again, the 3 comes down, the 1 comes down. That's a solution, so it's aqueous. We're reacting it with calcium nitrate. Okay, CaNO3, 2. Again, 2 comes down, 1 comes down from drop and swap. And then I'm going to get calcium phosphate. That's going to be my solid, guaranteed, because the next chemical is potassium nitrate, has nitrate in it, so it must be aqueous. Now, if I just look at the information given in this question, it's given me some volumes and concentrations of these, okay? So I can calculate moles of both of these chemicals. Whenever a question, guys, asks you to calculate the moles or the mass of something, but gives you information about two chemicals, right away, it's a limiting reagent question, right away. Give us information about both reactants, and it's asking us about, sorry, my chair. It's asking us about a product, okay? So let's figure out what we can do. So first thing that we need to do when doing stoichiometry, now that we have our chemical equation, is balance it. 3 potassiums, 3 here, 3 nitrates, okay? I've got, well, actually, we'll do it this way. I got 3 calciums here. I got 1 here. Let's put a 3 there. I now have 6 nitrates. So I got to put a 6 here. I've got 6 potassiums. I have 3 here, 2 there, 2 phosphates, 2 phosphates. Okay. So let's just start again with the stoichiometry part of this question. Again, this is to calculate the theoretical yield. Okay. And I'll get into that in a second. But so far, they've given us a volume of potassium nitrate, which is 85 milliliters. But we want liters. And they've given us a concentration. Right away, if I have volume and concentration, let's just calculate moles. We know how to do that. We're pros at it now. Again, make sure your chemicals are in the proper units, moles and liters. Liters cancels. Okay, 0.01462 moles. All right, good. Now let's calculate the moles of the other chemical, because they also gave us that information. If they give me information about both, I can't just choose which one to do. I have to use both. Volume is 120. Okay, divide by 1,000 to get liters. Concentration 0.144 moles per liter. And is C times V. Okay. I'm going to get 0.01728 moles. All right. If I, again, just look at these, I'm going to predict which one's going to run out first. Smaller number, probably going to be this one. But we remember that what we have to do to figure out the limiting reagent is divide by where you start the chemicals to figure out how much will react. These are the total moles that are present, but the total moles present doesn't necessarily mean how much will react. So let's divide this one by 3. I'm going to get 0.00576. Okay. Divide this one by 2. Zero point 0.01462 divided by 2. Oops. I'm going to get 0.00731. Well, that's interesting. We thought this one was going to run out first, but it's a bigger number. So therefore, this, guys, is my limiting reagent because it is a smaller number. Okay? So that means we're going to finish riding a roller coaster with that guy. All right. So to finish riding the roller coaster, we divided by where we start. We have to multiply by where we're going, which is 1. So the moles of this chemical will be the same because we're multiplying by 1. I probably can figure out the molar mass of that chemical using my data booklet. All right, let's get that in here. There are 3 calciums. Calcium is 40.08. There are 8 oxygens, so 16 times 8, plus 2 phosphoruses, which will be 30.97 times 2. Okay, 310.18 grams per mole. All right, so to figure out the mass of that solid, just multiply those together. And we're going to get 1.7866 ... grams. Sig bigs 1.79 grams. All right. What did we just calculate? Did we do an experiment here on this whiteboard? Did I go into the lab and do this experiment with this information on this whiteboard? No. I haven't. All I've done, guys, is calculate something. I calculated what I should get in theory if I did this experiment in the lab. Therefore, this right here is our theoretical yield. It is what we should get if we did this experiment in the lab. What does that mean? That means, guys, if you ever want to calculate the theoretical yield, you have to do stoichiometry. Okay? So this right here, guys, has given us the theoretical yield. Has not given us the percent yield. Okay? It's given us the theoretical yield. However, let's read the rest of this information. It told us that we did the experiment, and it gave us the mass of dried filter paper, just that little, it would be like a tissue paper, okay? Mass of filter paper. And then on top of it, you have your precipitate, okay? So imagine the marker is the precipitate and the tissue paper is the filter paper. And it gave us that mass. We don't care about those masses, we care about the difference between them because that will be the mass of the precipitate. It will be the mass of both of them together minus the mass of the filter paper, which will be 1.71. So what this is saying, guys, is we did the experiment and this is what we got experimentally. So this is our experimental yield, theoretical experimental. So guys, we can now calculate the percent yield. The percent yield is experiment over theoretical times 100. Okay. Hopefully you guys can still see. I know it's getting smaller. So experimental is 1.71 My theoretical yield is 1.79, but I did round that number. So I would recommend using the unrounded number of 1.7866 ... grams to just get a little more accurate. Okay. So let's do that. So 1.71 divided by your unrounded answer. Again, this is my final answer if I ended the question. Because I'm doing percent yield, I want to be as accurate as possible and use that unrounded number. Multiply that answer by 100, guys, and you're going to get 95.7%, which we like to call 96%. And that's your percent yield. So in other words, this question, guys, asked us, how good did we do at the experiment? Okay, it gave us, we had to calculate the theoretical yield, what it should have been, and then we had to compare that to what we actually got doing the experiment. And guys, our experiment was 96% successful. So that's pretty good.